Here we are with the final challenge question of Chapter 2, Functions and Graphs, Year 2 at Excel. Okay, Chapter 2. Right then, so challenge question is sketch 2 graphs. I think I'm going to start with the blue one. Okay, y equals the modulus of x plus a. So if we just had y equals x, it would come through here. And then if we had y equals x plus a, it would come through here and cut at a somewhere. But because it's the modulus, it's going to come through here and it's going to bounce off in that direction. Okay, so let's see if we can get this drawn roughly somewhere correct. Okay, it is going to be cutting through there at a. It is going to be hitting there at minus a, and it's going to be then shooting off into space there. So there is the y equals modulus of x plus a. Okay, next one, y equals a squared minus x squared. Okay, so we know if we have an x squared, that's x squared, and so if we have something like that, that's a minus x squared. And then because we've been told a is a constant, it will be coming raised up like that, okay, in some way, shape or form, something like that. And of course that will be the a squared up there. Okay, so in terms of what we are drawing here, we can draw a big, that's a terrible line. Let's see if we can go this way around and get it a bit better. There we go, like that. It's not a very good graph, but it will do. Okay, y equals a squared minus x squared. Okay, what do we get out of the coordinates? We've been asked for the coordinates of where we cut the axis. So for the blue graph, what just happened there? For the blue graph then, okay, for the x minus a, I don't think we actually have to do this one, but we can put the coordinates of the x-axis there of being 0 and a, and it also touches the graph down here on minus a and 0. What can we do with this one? Well, if you notice, a squared minus x squared is a difference of two squares, so we can do a minus x and a plus x, which means we get two solutions of a and minus a, which means I've drawn this thing awfully, okay, because it's meant to be going through the same point. So I'm just going to quickly change that around. Okay, now that I've just discovered that it goes through a on the axis. Okay, what is going on with this today? So it should be coming through here like that. And there's the minus a, that would be the a, and so the points where it touches would be minus a 0 and a 0. Okay, we have been told there is an intersection of these graphs at x equals 4. So presumably this point here is 4. Okay, find a. Well, what can we do with that? We can say that the y, the pink, okay, is a squared minus 4 squared, okay, and that is equal to the blue. Now we're on the positive of this, so it's going to be the 4 plus the a. Okay, for us to solve. So what do we get with that? Let's just put it all together then. So we've got an a squared minus a 16 minus a 4 minus an a is equal to 0. A squared minus a minus 20 is equal to 0. So that gives me some coordinates of what's it going to be? Not coordinates, but factorizations. 4 and 5. Let's have a minus 5, a plus 4, meaning that we've got a equal to minus 4 and a equal to plus 5. I'm pretty certain the question said for it to be a positive a. Yes, a is greater than 1, it says in part A, so we can disregard the minus 4 and be left with a equals 5. And I've just looked at the answers in the book. That's all fine for the a equals 5, but what I did do is I forgot to write down the coordinate of where the pink graph crosses the y-axis. I did speak about it as I was doing my explanation up here, but I didn't write down the actual answer, which of course would be an x of 0 and an y of a equals a squared. Y equals a squared. Okay, so that point up there is a squared. All right, which we now know is 25. Okay, right. And of course, we now see that the two blue ones there are the same as well. Right, done.